Okay, so we're going to be kind of combining two components on today's lesson. So sometimes you see the unit circle and it talks about the coordinates and special right triangles. Today we're going to be looking at the coordinates and their connection to, since these are a right triangle, they also fall into the whole formula of Pythagorean theorem, and how you can use the Pythagorean theorem to find your other coordinate here without actually having the unit circle in front of you. So as you can see here, we have what would normally be part of our unit circle given a radius, the radian of pi over 3 would plot me at my point at 1/2 comma square root 3 2, and that would be my coordinate at this point on my unit circle. So the question is, how does that relate to our Pythagorean theorem, and how are we going to make that leap of our trig to this formula? So this is kind of overwhelming at first, but let's go ahead and look at this. So sine basically is going to be working as our a in the Pythagorean theorem. And so that's our sine of whatever pi over 3 is, squared, plus cosine pi over 3 squared is going to equal to our hypotenuse squared, which traditionally is c, but we already know it's 1, so we're just going to stick with 1. So the sine of this quantity, squared, plus the cosine of this radian, squared, equals 1 squared. Plug it in to our Pythagorean theorem. So if you actually go to your calculators and make sure that you're in radian, you can type in sine square root 3 divided by 2, or you can actually type in pi divided by 3, the sine of it, and you will get square root 3 divided by 2. And that quantity, what sine is at that point, is what we're going to square. So we do the same thing for our cosine. You could actually go to your calculator and you can hit cosine of pi divided by 3 and hit enter, and you'll get 1/2. And so we're going to take that value, the cosine, which is the same thing as my b, that's this length here, it traveled that much, and be able to plug it in. And we're going to square it. So what we have is then this times itself, this times itself. That breaks out the radical, which gives us 3/4. 1 times 1, 2 times 2, which gives us 1/4. And those all together gives us 1, which is a true statement. So this is part of confirming the Pythagorean theorem that these quantities, the sine of your coordinate squared plus the sine of your coordinate squared, does in fact equal the hypotenuse, which is 1 squared. Is the previous page kind of important because we wanted to make that connection between the Pythagorean theorem and the fact that I can actually rewrite the Pythagorean theorem using the trig function sine and cosine to make it look like this. And it's actually the same process. This is basically my y squared, this is my x squared, and together they equal 1 squared, which is 1. You have your a and b, which is one side squared and plus the other side squared, and it equals c squared. They're the same thing, just one using trig function, one using a and b. So with that, I can actually start doing a solving for certain sides, which means I can subtract b squared from this side. I can do it to this side over here because I'm going to start solving for a and try to figure out how much is that one length worth. So I can do the same thing over here. I can subtract cosine from both sides because over here I'm trying to find my y, which is sine. Here I'm just trying to find length a in terms of b and c. So that would give me that quantity. If I do it over here, then I'd just end up with sine squared of theta equals 1 minus cosine squared of theta. Same thing, just with looking different in trig function. So to take that, I then have to take the square root of both sides to undo my square here. So I do the same thing over here. That would give me a equals the square root of c squared minus b squared. And so over here, what I find is that sine actually equals the square root of 1 minus cosine squared. Theta, excuse me. So I can then solve for sine theta if I know what cosine is, because all I have to do is square the cosine theta and subtract it from 1 and square root it. And that quantity would be sine. So also, then, if I want to solve for b, I could do the exact same basic steps and minus my a from both sides, my squared. I can minus my sine squared. I'm going to do all the same mathematical steps up here to get to my final answer. And I'm going to do all the same mathematical steps up here to get my final answer. So what I'm left with are these two really important functions, or excuse me, formulas that says this is what you do to find sine given cosine, and this is what you do to find cosine of a theta given sine. And that's same thing as what it would look like as Pythagorean theorem. This is also very similar to the distance formula, same basic concept, but yeah, just with trig functions. So make sure you pause the video and copy those down. So let's go ahead and look at this in an example. So let's say we're told to find sine theta given cosine pi over 3. Okay, so things that we're going to look at is 1. If we're looking for sine, we're going to first write down our formula and acknowledge the formula that we need to be able to solve for it, which is our square root of 1 minus cosine squared theta. And then from there, we're going to set up that exact equation, but since we have been given our theta, we're going to substitute it in and plug it in. We're going to go to our nifty calculator, and you can actually figure out in terms of what is the cosine of pi divided by 3. And that quantity is going to have to be squared. So that is 1/4. So I have 1 minus 1/4. I'm going to basically turn this into 4/4 minus 1/4. And I get the radical of 3/4. So remember, when you do that, you're going to do radical 3 and radical 4. The square root of 4 is 2. The square root of 3, well, that's just going to stay sine theta equals square root 3 over 2. That is my answer. If you actually go to the unit circle and look at radians of pi over 3, you will find that the cosine is in fact 1/2, and that the sine at that radian on the unit circle is radical 3 over 2. Which, want to make sure we kind of practice starting to put it into a decimal form, as that will come in handy later of a plus negative. All right? So we'll look at another example. Pause it, copy it down. So let's say we're asked to find cosine theta given sine at a said radian. So we are going to then say, okay, that's the formula that I need to use to find cosine. I'm going to write my formula and substitute in my theta. Oops. I am then going to go to your nifty calculator, and you can rewrite it as radical 3 divided by 2 and square it. If you happen to have it in decimal form, that is perfectly okay to keep it in decimal form and just square that decimal, which ended up being 3/4. So again, I'm going to do 4/4 minus 3/4, which leaves me with 1/4. I'm going to take the radical of my numerator, radical of my denominator, and I end up with the plus and negative of 1/2 or 0.5. So this is the initial process. We then can take that information and do more with it. But for right now, we're just going to be practicing of how to be able to even find the other trig function based on, or the given trig, the trig that we've been given. All right. Well, I hope this helped.